In the last few months, there have been some really intriguing discoveries in regards to unusual exoplanets. Planets that seem to be weird or strange or just unexplainable for one reason or another. And planets that I wanted to discuss in this video, mostly dividing this into two separate parts or two separate videos. Planets discovered by telescopes other than James Webb, with the second one focusing on just the James Webb discoveries. Mostly because there's just no comparison. James Webb has been able to explore so many more planets than anything else we have, and so it does deserve a separate video. But on that note, hello wonderful person, this is Anton. Today we're going to discuss strange planets. And mostly because it looks like we basically live in the age of astronomy, and by extension also the age of exoplanetary discoveries. With all of this starting approximately 15 to 20 years ago, with this right here being one of the first images. This is actually Beta Pictoris, one of the most iconic exoplanetary pictures, with a direct image of a planet visible right there. And this was at a distance of 63 light years away from us, and actually a star system that's technically visible to the naked eye. But it did take a few modifications to the European Southern Observatory in order to be able to capture this planet for the first time. But after 15 years, we obviously have so many more better observations of this planet, as you can see from this video, with the data collected over many years. Intriguingly, this was also the first direct evidence of the existence of exocomets, comets in other star systems. But technically this is, I guess, old news. Let's talk about some of the more recent discoveries, which are a lot more unusual. And the first one is from a star system approximately 73 light years away from planet Earth, a star system known as HD 63433. And here one of the planets, planet D, that surprisingly seems to have very similar mass and very similar radius to planet Earth, is now believed to be a very intriguing lava planet. Essentially, it's so close to its star, which is very similar to our Sun, that it's always facing with the same side to the star, and that side very likely became extremely hot, possibly around 1300 Celsius or 2400 Fahrenheit. And so what makes this star system so unusual and I guess somewhat intriguing is the fact that the star and the planet are extremely similar to the Sun and planet Earth, except for the distance. It's as if we had Earth orbiting at a location where a single year is only 4.2 days, making that one side super hot, but what happens on the other side right now is still unknown. But future observations will hopefully tell us a little bit more about these types of planets. One side is potentially all lava, other side we don't really know. Then we have something a little bit more intriguing. This is a star system known as Gleise 367. It's one of those systems that has a proper name, and in this case I'm going to butcher it. I guess it's Anyanyusa, one of those. It's approximately 31 light years away from us, and it's basically a red dwarf. But the closest planet, Tahai, or 367b, is a really strange planet. First of all, it's extremely close to the star. Actually, in this simulation you can even see that there's an unusual tail that's technically formed by this planet. But in essence, it's so close that a single orbit is only about 7.7 hours. Once again, naturally making this a very hot planet. But that's not the strange part. The strange part is its density. It seems to be way too dense. Approximately twice as dense as planet Earth, suggesting that this could be actually pure iron or a composition of some other very dense metals. In this case it has approximately 63% the mass of planet Earth and about 70% Earth size. And so if you do calculate the density, it seems to be a little bit too high, which right now suggests that maybe this is actually a kind of a core of an ancient planet. A core that had even the rocky mantle completely stripped away. And though it's unclear how this would happen, the only possible explanation we have right now basically involves some kind of a major collision. This could have been some kind of a Neptune-like planet that collided with something else, which made it lose a huge part of its mantle, but also made it migrate much closer to the star, which as you can see right here, would also strip away any atmosphere that it had, making it just a pure chunk of metal. And previous discoveries of very similar collision-stripped planets have always been in systems with multiple planets. It's pretty much the same case here. There are several planets here in a relatively tight orbit, which does imply that maybe some kind of a collision is the best explanation. And so at least for now, this is maybe a mystery, but definitely a super intriguing discovery. But this wasn't the only unusual dense planet discovered recently. There were actually a couple more with even stranger parameters, but technically kind of similar explanations. First one is TOI 1853b, a gas giant surprisingly much smaller than Neptune, making its density once again the density of Earth. But unlike the previous object, it's unlikely to be a pure metal core. Instead, it's believed to be quite enriched in silicates and various types of rocks, and may actually once again be some kind of a core of a much larger planet, possibly even similar to Jupiter. And so here we might have yet another stripped core, but in this case of something much bigger. And so if this was a core of maybe some kind of a small gas giant, here we seem to have a core of a much larger giant, making something as big as Neptune, but with a total mass of 73 masses of Earth, almost 5 times more massive than Neptune. And so here the density is once again extremely high and cannot be explained in any other way than maybe some kind of a collision. Now we obviously have no idea what this planet might look like, and it might still have some atmosphere on the surface, mostly because it's pretty massive, but because it orbits the star every 1.2 days, it's extremely likely to be once again very hot. Although here, in order to form this object, it would have to experience some kind of an extremely rare collision between two really large gas giants, basically two Jupiters colliding together. And though it's quite possible that this is what happened, this would be relatively rare. But apparently not rare enough, because around the same time, a very similar planet was discovered elsewhere. A planet known as TOI 332b, 57 Earth masses, approximately 3.2 Earth radii, with a very similar density of 9.6 grams per cubic centimeter. So almost double of planet Earth, and very similar to that other planet, which basically suggests that this is maybe a new type of a planet, or maybe a very common phenomenon after all. Basically planets colliding, forming something entirely different in the process. Intriguingly, if these planets did collide, they would actually have to do this at extremely high velocities with a huge amount of energy, possibly going as fast as 75 kilometers per second, which most likely resulted in an enormous explosion, which would be visible from really far away. And we might have discovered something similar but on a much smaller scale a few months ago. You can learn more about this in one of the videos in the description. Then we had an unusual discovery, or I guess a direct confirmation, that a planet known as WASP 69b, a gas planet extremely similar to Jupiter, seems to contain a very long comet-like tail, roughly around 500,000 kilometers long, or about 7 radii of the planet. Now this is of course something that's expected and something that we know even exists here in the solar system, because we do see certain tails from Mercury, but in this case it really seems to be because the atmosphere is escaping at an extremely high rate, 200,000 tons per second. And this is definitely the highest rate of atmospheric loss seen anywhere. And by studying this, it will definitely help the scientists figure out how various planets change over time. And interestingly, most stars discovered so far that contain planets will usually have some kind of a planet in an extremely close orbit, much closer than Mercury. And so most of these planets, and by extension most stars out there, might actually experience this to some extent, eventually transforming these planets into something very different and very likely something we do not really have in the solar system. But because here we can study this mass loss in real time, it will eventually lead to some new propositions and very likely new explanations. In case you're wondering, most of this tail is hydrogen and helium. But because this planet is relatively massive, approximately 90 masses of Earth, it can actually lose this atmosphere for a very long time. And so it will definitely take billions of years for it to become something different. Because it really looks like collisions tend to transform planets instantly, but the atmospheric loss might take quite a while. But around the same time there was also another discovery in regards to these very close planets, very massive planets in a lot of different star systems. We normally call them hot Jupiters. And essentially one of the recent studies discovered a direct link between the age of the star and the number of hot Jupiters. It looks like hot Jupiters are a lot more likely to be found around young stars, and they seem to disappear as the star gets older. And it could be maybe because of this gas loss, or potentially because they get swallowed by the star. Either way though, looks like mostly young stars will contain these unusual planets. And there was definitely no link between cold or warm Jupiters, or basically gas giants, slightly farther away. But another study was actually able to observe something super exciting on the surface or in the atmosphere of these extremely hot planets. In this case, a planet known as WASP 121b, roughly around 900 light years away from planet Earth. And here we have several years of observations which were then modeled to represent various weather patterns that seem to happen on this gas giant. And the actual weather here seems to be very dynamic. Much more dynamic than any gas giant in the solar system. And the reason for this is because, well, it is very hot. It takes approximately 31 hours to orbit around the star, And as you can see from the simulation right here, it's basically almost touching the star. And so by observing a lot of different changes in temperature on the surface of this planet, the researchers were able to create a very specific model that then led to simulations visible right here. So just to clarify, these are not the actual images, these are just simulations based on a lot of temperature data received by Hubble telescope. And so because of these very extreme temperatures, and also because the planet is most likely tidally locked, it seems to evaporate iron on one side, along with a lot of other metals, which then results in basically metal rain or iron rain on the night side of the planet. But all of this generated through huge cyclones, a lot of swirling, and massive amounts of activity in the upper atmosphere. Much faster than anything we see on Jupiter. With some of these storms and cyclones only very likely existing for mere hours. Whereas we know that on Jupiter they can actually exist for decades. And all of this was essentially discovered by seeing differences in temperature in different parts of the planet and also detecting different chemical composition, which basically represents the first ever simulation and the first ever analysis of actual weather patterns on a different planet somewhere out there. And using this modeling, we can now apply this to many different planets out there, so we can only expect a lot more discoveries in the future. And then we have a discovery that's strange for a different reason. A planet with a very unusual orbit. Here we have a star system known as AC Herculis, a star system 4,000 light years away from us. And what makes this particular star system somewhat unusual is the fact that it has a disk and a planet, but they seem to be basically in a kind of a polar arrangement. In other words, it has what's known as the polar circumbinary disk, whereas the stars, the binary stars, orbit in a different plane. Here's what the exact configuration here looks like. And so basically we have a double planetary disk, 2 stars, and then a planet inside this gap. Although to be more exact, it's not exactly polar, it's approximately 81 degrees. But what makes this system even more unusual is the fact that this is a really old system. It's actually a system that's already gone through its red giant stage, meaning that it technically should have destroyed all of the planets in the past. And so in this case, this planet might actually be a second generation planet that was created from the debris left behind after the planets were destroyed. But exactly why all of this is in polar formation is of course currently unknown. Although in this case, it looks like this unusual disk is actually feeding even more material into the same cavity, and so there might be even more planets forming right now. And so this is definitely a somewhat unusual discovery. But definitely not the last unusual discovery, because we'll be discussing even more that were discovered by the James Webb in the next video. And so at least for now, that's pretty much all I wanted to mention. You can find all of the additional links and studies in the description below. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.